Good morning to all of you. Now we are going to discuss about probability. Before discussing probability, you have to know about some basic concepts like random experiment, outcome, sample space, event, and so on. An experiment is called a random experiment if all possible outcomes are known in advance, but we cannot predict it. For example, if we throw a die, then possible outcomes are what? 1, 2, 3, 4, 5, and 6. We know it, but we cannot predict actually what result we will get. Therefore, throwing a die is an example of random experiment. Similarly, tossing a coin is also an example of random experiment. An outcome is a single result from an experiment. The set of all possible outcomes of the given experiment is called the sample space. An event is a subset of a sample space. Next, calculating probabilities. Look again at the example of rolling a 6-face dice. The possible outcomes in these experiments are 1, 2, 3, 4, 5, and 6. So the sample space of these experiments is the set 1, 2, 3, 4, 5, and 6. The event of getting a 6 is the subset singleton set 6. We represent it in the following diagram. Here see that the universal set represent the sample space and the singleton set 6 represent an event. There are 6 possibilities in the sample space and only one of these corresponds to getting a 6. So the probability of getting a 6 when you roll a die is 1 by 6. Now we say that probability of an event A occurring is total number of elements in A divided by total number of elements in the sample space. Let us take an example. If a fair coin is tossed, it is clear from our definition of probability that the probability of obtaining a head is 1 by 2. Similarly, probability of obtaining a tail is 1 by 2. There are various examples. Next, we discuss various types of event. First one is complementary event. If an event is a certainty, then its probability is 1. And remember one thing, that the probability of an event is always lies between 0 and 1. If an event is a certainty, then its probability is 1. For example, in the coin tossing experiment, let C be the event obtaining a head or a tail. The sample space of this experiment is what? The set H and T. The event is what? H and T, because C be the event obtaining a head or a tail. Therefore, the event is H and T. So, the probability of C is 2 by 2, because the total number of elements in the sample space is also 2, and the total number of elements number of elements in the event is 2. Therefore, probability of C is 1. Similarly, take another example. If a normal die is rolled, what is the probability that the number showing is less than 7? If a normal die is rolled, then the sample space is what? The set 1, 2, 3, 4, 5, 6. And the event is what? Here we are going to find the probability that the number showing is less than 7. Therefore, the event is what? The set 1, 2, 3, 4, 5, and 6. Therefore, the probability of number is less than 7 is what? 6 by 6. This is also 1. Therefore, if an event is impossible, then its probability is 0. If an event is certain, then its probability is 1, and if an event is impossible, then its probability is 0. Take an example. Find the probability of throwing an 8 on a normal day. Here, see that there are no possible outcomes in the event. Therefore, because the sample space is what? 1, 2, 3, 4, 5 and 6. And we have to find the probability of throwing an 8 on a normal day. We cannot get 8 in this experiment. Therefore, the event is what? The empty set. Therefore, the probability of throwing an 8 is what? 0 by 6, which is 0. If the event is neither impossible nor certain, then clearly its probability is between 0 and 1. If the event is impossible, then probability is 0. If the event is certain, its probability is 1. If the event is neither impossible nor certain, then the probability is always lies between 0 and 1. Two events are complementary if they cannot occur at the same time and they make up the whole sample space. For example, when a coin is tossed, the sample space is H and T, and the event H is what? Obtain a head and T obtain a tail are complementary. If we calculate the probabilities, we find that probability of H is half and probability of T is half, and probability of H plus probability of T is 1. Similarly, if a die is rolled, let A be the event, a number less than C less than 3 is obtained, and B be the event, a number of 3 or more is obtained. Therefore, probability of A is what? A is the event, a number less than 3. Therefore, this event takes only the value 1 and 2. Therefore, probability of A is what? 2 by 6. Similarly, B be the event, a number of 3 or more is obtained. Therefore, B is what? B equals to 3, 4, 5 and 6. Therefore, probability of B is what? 4 by 6. So, probability of A plus probability of B is 1. Therefore, we come at the conclusion. If two events are complementary, then their probabilities add up to 1. Take another example. A marble is drawn at random from a bag containing 3 red, 2 blue, 5 green and 1 yellow marble. What is the probability that it is not green? There are two ways of doing this problem. Method 1, see that we can work out the probability then that the marble is green. Here see that there are 5 marbles. Therefore, probability of there are 5 green marble. Therefore, probability of green marble is what? 5 by 11, because there are total 11 marbles. 3 plus 2 plus 5 plus 1. There are total 11 marbles. Out of them, 5 are green. Therefore, probability of green marble is what? 5 by 11. Since a marble is either green or not green, therefore, the probability that it is not green is what? 1 minus 5 by 11. Because we know that total probability is always 1. Therefore, the probability of not green marble is what? 1 minus 5 by 11. 5 by 11 is what? Probability of green marble, and not green marble is what? 1 minus 5 by 11, which is 6 by 11. Alternately, we can find the probability that the marble is red, blue or yellow, which is 6 by 11. Therefore, not green marble is what? 6 by 11. Next, mutually exclusive events. two events are incompatible, disjoint, or mutually exclusive when the occurrence of one precludes the occurrence of the others. That is, they cannot occur at the same time. For example, we cannot never have the head side and the tail side of a coin face up at the same time. For example, if a die is tossed, then the events E is what obtaining an even number and O obtaining a 1 are mutually exclusive, because see that from this diagram, E is what obtaining an even number. And here we consider the experiment is what a die is tossed. Therefore, possible outcomes are what 1, 2, 3, 4, and 5, 6, and the event E is what obtaining an even number. Therefore, E takes the value only 2, 4, and 6, and O is what obtaining 1. Therefore, this one is represent the O event, and 2, 4, 6 represent the E event. From this diagram, it is clear that these E and O are mutually exclusive. These are not intersect. Notice that probability of throwing an even number or 1, 2, 3, 4, and 6 is 4 by 6. This one is probability of E plus probability of O. Next, we state the addition law for mutually exclusive event. We know the addition law of any two events. Suppose A and B are any two events, then probability of A union B is what? Probability of A plus probability of B minus probability of A intersection B. But if A and B are mutually exclusive, then they are disjoint. Mutually exclusive means what? A and B are disjoint. Therefore, probability of A intersection B is what? 0. Therefore, we get the addition law for mutually exclusive event. Probability of A union B is what? Probability of A plus probability of B. Here this part is vanished because here probability of A intersection B. This part is vanished because probability of A intersection B is 0. Thank you.